second study session. In this session, we will be looking at Class 10 Physics chapter number 1, which is chapter 9 in your textbook. The chapter name is Light, Reflection and Refraction. Before moving into the chapter, don't forget to like, share and subscribe to my channel. Come, let's go. The lesson we are going to look at is chapter number 9, Light, Reflection and Refraction. The first topic we need to understand is reflection of light. What do you mean by reflection of light? Come, let's understand. You can see that a ray is coming and hitting the mirror. When this ray hits the mirror, it is bouncing back into different direction. Look at here, this ray is hitting the mirror and then it is bouncing back into different direction. This ray, which is coming from the light and hitting the mirror, is called the incident ray, and the ray that is bounced back is the reflected ray. The line between these two rays is normal. The incident ray with normal forms an angle called angle of incidence, and this reflected ray forms an angle with normal, which is angle of reflection. According to law of reflection, this angle and this angle are equal. Come, let's study the law of reflection. As I said, angle of incidence is equal to angle of reflection. This is angle of incidence and this is angle of reflection. These two angles are equal. Incident ray, which is this ray, the normal, which is this line, to the point of incidence. This point is point of incidence. Reflected ray, which is this ray, all lie on the same plane. Everything happens on the same mirror, right? So they are telling that the incident ray, normal to the point of incidence, reflected ray, all lie on the same plane, which is the mirror. Now let's study the properties of plane mirror. What is plane mirror? The dressing mirror that we have in our home is an example of plane mirror. This plane mirror will always give you a virtual and erect image. Erect means straight image. Virtual is not the real image. Your appearance will be laterally inverted. That's why they said that the image formed on the plane mirror is laterally inverted. The size of the image is equal to that of the object. Our height and the image obtained on the mirror's height is always same when it is obtained on the plane mirror. The distance between the image obtained is the same as the distance between the object from the mirror. This is the plane mirror. Now let's keep this object in front of this mirror. See here, this object is laterally inverted and the height of the object is equal to the height of the image formed. Can you observe that? And the distance between the object and the mirror and the image is always equal when the image is obtained on plane mirror. I hope you understood the properties of plane mirror. Let's take a spoon. You can observe that this is curved outwards. Therefore, let's consider this to be the shaded region and this as the reflecting surface. So, this denotes it is a concave mirror. While when we turn the spoon, we consider this to be the shaded region and this as the reflecting surface. This is convex mirror. Let's see how image forms in the concave and convex mirror. First, let's see how image appears on concave mirror. I have a Christmas tree. I am placing this Christmas tree right here. Can you see? The image of the Christmas tree appears inverted. Now let's consider my hand. My hand is inverted, but when I take my hand too close, it appears virtual and erect. Let's study about all these image formations very clearly when we study in the topic image formation on concave and convex mirror. Now let's understand very clearly about what is concave and what is convex mirror. This is concave mirror and this is convex mirror. You should remember that C denotes convex mirror, and when the C is laterally inverted, it is concave mirror. When you remember this, you can easily draw the ray diagrams. We have considered this to be a hollow sphere, right? So this midpoint is the curvature of both the concave and convex mirror. Curvature is the midpoint of the sphere. In concave and convex mirror, this C denotes the center of curvature. You should always remember that when you draw a concave mirror and convex mirror, you should mention these three parts. This is curvature, midpoint, focus is this point, pole is the center point of the reflecting surface. This is reflecting surface, right? So the center of this reflecting surface is pole. When you draw concave or convex mirror, you should always remember to mark the shaded region. Remember that the shaded region of concave mirror is outer and the shaded region of convex mirror is present inside. Okay. Now let's understand what is focal length. The distance between the principal focus and the pole is considered as focal length. The length between curvature and pole is radius, as we know. So we can conclude that focal length is half of radius. Distance between the curvature and pole is radius. When it is divided into half, you get focal length, which is the distance between focus and pole. This line is called the principal axis. All these points are very important when you draw a concave mirror and convex mirror. This capital C denotes curvature, capital F is principal focus, small f denotes the focal length, pole, capital P denotes pole, capital R is the radius of curvature. Concave mirror, a spherical mirror whose reflecting surface is curved inwards. This is the reflecting surface of concave mirror, right? So it is curved inwards, as you can see in the spoon. It is curved inwards, that is faces towards the center of the sphere. Already told that curvature is the center of the sphere. So the reflecting surface of concave mirror faces towards the center. Now let's understand what is convex mirror. Convex mirror is also a spherical mirror whose reflecting surface is curved outwards. I have already told you this is the convex mirror. So the reflecting surface of the convex mirror is curved outwards, that is opposite to concave mirror. Now let's understand what is principal focus. This activity is given in your textbook. In this activity, we are taking a concave mirror. This is the concave mirror that we took for the experiment. And when we keep a paper here, we can observe that the parallel light rays from the sun gets reflected and the reflected ray all meets at a point called focus. This point in the paper will start to burn as the sunlight is falling on it. Now we also understood that rays that are passing parallel to the concave mirror are reflected to a point called focus. This shows that concave mirror is converging. Converging means all the incident rays that are passing will converge at a particular point, whereas the light rays passing through convex mirror will diverge as they pass. That's why they are called diverging mirrors. When the incident rays pass parallel to the principal axis, which means the incident rays are passing parallel to this principal axis, are meeting at a point on principal axis, which means principal focus. Aperture is the diameter of the spherical mirror. Now let's understand how the direction of incident ray changes the direction of reflected ray when it falls on spherical mirror. Look at here. The incident ray is moving parallel to the principal axis. So when it moves parallel, the ray bounces back and goes towards the focus. This is concave mirror. If the same situation happens in convex mirror, the incident ray passing parallel to the principal axis and the reflected ray when extended also passes to the focus. So a ray parallel to the principal axis after reflection will pass through the principal focus. When the incident ray is parallel, the reflected ray will pass through focus. Now let's see. In this image, we can observe that the incident ray is passing through focus. Then how will the reflected ray move? When incident ray is passing through the focus, the reflected ray will be parallel to the principal axis. The same way in convex mirror also, when the incident ray is passing through focus, the reflected ray will go parallel to the principal axis. When a ray passes through the center of curvature, This is reflected ray. As you can see, there is no change in the direction. So the incident ray and the reflected ray all go through the same path. Similarly, in the convex mirror also, this is the incident ray. When it passes through curvature, it is reflected back in the same path. Now let's see incident ray passing through pole. When it passes through the pole, it reflects obliquely. The angle of incidence and the angle of reflection are equal when the incident ray passes through the pole. Similarly, for convex mirror also, when it passes through the pole, it reflects obliquely. This is very important for you to understand how image forms when the object is kept at different distances. Come, let's understand how image forms on concave mirror. I have drawn 6 concave mirrors. The position of the object is going to change when in each mirror. First, the object is at infinity. Let's draw an object which is at infinity. We should always name the object as A and B. The rays passing from this object will fall on focus. This point is the point where all the reflected rays meet. All the reflected rays meet at the point called focus. Therefore, the image formed when the object is at infinity is very small. That's why we say the size of the image is point size. When the object is at infinity and the rays pass to the concave mirror, all the reflected ray falls on point called principal focus, and the image formed is very small. That's why we say that point sized image is formed when the object is at infinity. The image formed is real and inverted. When the object is at infinity, the rays passing from it are parallel, and when it hits the mirror, all the reflected ray meets at the point called focus. So that's why the image formed is too small. That's why we say that it is point sized image. The image formed is real and inverted. Let's see what if the object is placed beyond C. C is nothing but the curvature. Never forget to name the object. Incident ray is passing parallel and the reflected ray is passing through focus. You should always remember to put these arrows. This is incident ray and this is reflected ray. Another incident ray passes through focus and the reflected ray is passing parallel to the principal axis. Another ray is passing from B to the curvature. So, we already studied that whatever ray passing through the curvature is reflected back in the same path. That's why we drawn the arrow, incident ray and reflected ray in the same path. Now, you can observe that the two incident rays passing from A and those respective reflected rays are meeting here. And the ray passing from B is reflected back in the same path. So, the image that is formed is between C and F. Okay, you should remember that when the object is kept beyond C, the image is formed between curvature and focus. You can observe that the height of the object is bigger than the height of the image. Therefore, the image is diminished, which means the image size is smaller than the object. How can we name the image? I have already told you the reflected rays belonging to the incident rays passing from A meet here. So let's name this as A dash. This reflected ray is from B. That's why we are naming it as B dash. So A dash B dash shows that the image is inverted. That's why we say that the image formed is real and inverted. Now let's keep the object at curvature. and name it as A and B. When the object is at curvature, a parallel incident ray another ray is passing through the pole you can observe that the image is formed here. How can we name the image? We always know that the image formed in the concave mirror is real and inverted except one position. That's why we name it as A dash and this as B dash. You would have observed that the size of the object and the size of the image is same. Whatever object is placed at the curvature forms the image at the curvature. The image is real and inverted, and size of the image is same size as that of the object. The position of the image is also at curvature. Now we are going to place the object between curvature and focus. Find the ray that is passing through the curvature. Another one is passing through the pole. The ray from B is passing through the curvature. All three reflected rays are joined and we get the image to be inverted and enlarged. The size of the object is smaller when compared to the size of the image, right? So the image formed is enlarged and the image is real and inverted. The position of the image formed is beyond C, which means it is beyond the curvature. Now the position of the object is at focus. Ray from A is passing through curvature. Another ray is passing through pole. Here you can observe that the reflected rays are getting closer and they will all meet at some point, but that point is at infinity. That is why we conclude that the image formed is at infinity and the image will be highly enlarged, because when these two lines, if they are meeting here and this reflected ray is going here, the image will be highly enlarged. And we can also conclude that the image is real and inverted because the rays that are passing from A are meeting here and the ray that is passing from B is here. So B dash and A dash, real and inverted. Now we are placing the object between focus and pole. I am drawing a ray that passes through curvatures. Another ray is passing through the pole. We can notice that these two rays are not going to meet at any point. So what we need to do, we need to extend these lines. And we are making the rays to meet. Now we are drawing the image. Here you can observe that the rays that are passing from A are meeting here. So we name it as A dash. And this ray from B is meeting here, which is B dash. You will be able to observe that all concave mirrors except this one are forming a real and inverted image. While when the object is placed between focus and pole, the image obtained is virtual and erect. Look at here. When the object is placed at infinity, we are getting the image at focus. The image is highly diminished point-sized image and it is real and inverted. When the object is placed beyond C, we are getting the image between C and F. Image is diminished, real and inverted. When the object is placed at curvature, we are getting the image at curvature, which is same size, real and inverted. When the object is placed between C and F, we get our image beyond C, enlarged, real and inverted. When the object is placed at focus, we are getting the image at infinity, highly enlarged, real and inverted. So when the object is placed between pole and focus, we get the image behind the mirror. The image is enlarged and virtual and erect. You will be able to observe that all the images are real and inverted except this one, which is the object when placed between pole and focus, you will get a virtual and erect image. Now let's learn applications of concave mirror. Concave mirrors are used in torches, searchlights, headlights, shaving mirrors. Dentists also use concave mirrors to see the enlarged image of the teeth. And we also use big concave mirrors for solar furnaces. Let's understand how image is formed in convex mirror. When the object is placed at infinity, the rays are passing parallel to the principal axis. As this is the reflecting surface, it is bouncing back here. We need to extend those lines to get the image formation. When we extend these lines, we can observe that the image is formed at focus. The image formed is virtual and erect and it is point-sized image. Virtual and erect, size of the image is point size. And the image formed is at focus. Now let's see when the object is placed between infinity and pole, how the image is formed. Rays from A are passing parallelly and they are reflecting. Another ray is passing through focus. We already seen that when the ray is passing through focus, the reflected ray will be parallel to the principal axis. A ray from B is passing through the curvature. So it reflects back in the same direction. When we extend the reflected rays, we will get the image formed between focus and pole. Can you observe? The image is formed between focus and pole. Because the reflected rays of A is here and the reflected ray of B is here. When we join those two, we are getting the image here. So it is A dash and B dash. It is also a virtual and erect image. The image size is smaller than the object size. That is why we write it as diminished image. And it is formed between focus and pole. You can observe when the object is placed at infinity, we are getting the image at focus. The image is highly diminished point size image and it is virtual and erect. When the object is placed between infinity and pole, we are getting the image between focus and pole. And the image is diminished, virtual and erect. Let's learn the applications of convex mirror. We use convex mirror to see a full length image of tall building or tree. This is a one mark question that is usually asked. In which mirror we will be able to see the full image of the building or a tree or any other tall objects? You should say that it is convex mirror. It is also used in rear view mirrors in the vehicles, which helps the drivers to see the traffic behind them. It is also used in security mirrors. I hope you understood these concepts. We will be having a part 2 session of this video to complete this whole chapter. Share it to your friends too so that they will also get benefited. Don't forget to like, share and subscribe to my channel. See you guys in the next video. Thank you for watching.